Today topic is fluid dynamics. What is fluid dynamics? It is study of motion of fluid flow along with forces causing the flow. This is the fluid dynamics. Next is next, according to Newton's second law of motion, net force acting on the fluid element is equal to mass of fluid element, net force Fx. This is Fx, mass m of element is multiplied by this is in x direction, multiply by acceleration in the x direction. So according to the Newton's second law, Fx equal to m into, this is the net force, resulting net force, m to a into x. So net force equal to m into x. So fluid flow, the following in the fluid flow, following forces are present. Number 1, Number 1, gravity force Fg. The gravitational force. Number 2, the pressure force. Number 3, the viscous force due to viscosity. Number 4, T is the force due to turbulence. This is the force due to turbulence. Number 5, C is force due to compressibility. Note down. This is so due to resulting net force equal to Fx equal to Fg into, this is the x direction, Fp x direction, Fv x direction, and Ft x direction. This is the resulting net force. Now, number 1, if Fc means force due to compressibility is negligible, so the net force equal to resulting net force in x direction, resulting net force in x direction, Fx equal to Fg Fp into x direction, V into x direction, Ft into x direction. This is called Reynolds equation of motion. This is called Reynolds equation of motion. Understand? Number 2, if Ft, Fc, Ft are negligible, so resulting force in x direction equal to Fg into x, Fv into x, Fp and Fv into x. So this is the Navier-Stokes equation. This is the Navier-Stokes equation. This is very important. If number 3, if FC, FT and FV are negligible, then the net resulting force, so that time the net resulting force, this is the net resulting force in x direction is J. This is called Euler's equation of motion. Understand? Now derive the Euler equation. Euler's equation of motion. Euler equation of motion. Now consider a streamline. Consider a streamline in which flow is taking place in S direction. This is suppose this is the and consider a cylindrical element, cylindrical fluid elements or element of cross section dA and length ds. Suppose this is the cylindrical elements whose cross section dA and his length is ds. This is the streamline cylinder, the cylindrical shape. Suppose this is the dA. Understand? And ds, and the force acting on the element. Number 1, pressure force. Suppose this is the this is the dz height. height is digit. Pressure force this is pressure force P into dA. P into dA in the direction of flow. Direction of flow. Number 2, P into dP by ds into dP into dA. Now the pressure force P into dP into ds. Oh, so this is suppose this is the Taylor series equation. This one pressure, only pressure, ds into dA, opposite of the direction of opposite to the direction of flow. And number 3 is weight of the rho g weight rho g and dA into ds, weight of the element this 3 force. And theta is the angle between flow of direction. Suppose weight, this is W acting here. Pressure always acts compressive in nature and compressive of nature. This side is pressure along the direction of flow, and this side pressure is a normal compressive force. This is the opposite to the direction of flow. Theta is angle between the direction of flow and line of action of weight of the element. This is theta. Line of action of weight of the element. Action of the weight of element. Understand? Now consider the force. Now this is net resulting force equal to the direction of flow is considered positive and opposite of the direction of flow consider negative here. So direction of flow P into dA minus, and this is opposite direction, P into dP into ds into dA, and this also, this is omega, this is W, this is W cos theta, and W means this weight, minus this is also opposite to the direction of flow, dA into ds equal to cos theta equal to m, mass. We know mx into ax from max from Newton's second law of motion, and mass rho into volume dA into ds, and acceleration equal to acceleration equal to as, acceleration in the s direction. This is streamline. Now solve this p into dA minus p into dA, and the height is dz, minus dp into ds into dA, minus rho g dA into ds. Here suppose this is theta, this is dz, this is the ds, so cos theta equal to base dz by ds. So put the value cos theta here, dz by ds into rho into dA ds into as. Now cancel out this one, and this one also cancel out, and now I wipe this one. Now minus dp into ds into ds into dA, and I can minus into dA into dz, this also minus rho into dA into ds or equal to ds, and here dA and dA cancel out.